This is the first section of Chapter 7. If you're watching this and you missed class the first day of class, you will also need to complete the worksheet from my website. Before dealing with functions, we first need to discuss what a function is. A function, by definition, is when there is exactly one input gives exactly one output. I always take this back to the vertical line test. Given a graph, by definition, if for each input, so for each x value, there will be only one y value. The reason I take it back to the vertical line test is because the vertical line test tells us if it's a function or not. So at this x value, how many y values are there? There's one up here, there's one up here. This would fail the vertical line test, and it would thus not be a function. Given a second example, if you draw a vertical line through any portion of this, it will only hit it once, so that means for each of the x values, so for instance right here, this x value gives only one y value. That means it is a function. Ways that you can denote a function: you can have f of x, you can have g of x, you can also have h of x. Those are the three main ones that you will see. And given two functions, we can add, subtract, multiply, or divide the functions according to what it's asking us to do, and you'll see that in the next slide. Notice instead of saying add, subtract, multiply, divide, I'm using sum, difference, product, and quotient. And the first thing I want you to notice is the notation. So they would ask us to find this portion. They would say, what is f plus g of x? That is denoted using this. If we have f minus g of x, so everything's in parentheses, and it's of x, then we have to do the second operation. We're going to go through each of these, complete them, showing the steps required. On the sum, they're asking us to find what's in the box. Our first step is always going to be write f of x plus g of x. From there, it simply turns into a plug-in game. F of x is x plus 2, g of x is 3x, and when we put them together, it's 4x plus 2. Similarly, on the second one, they're going to ask us to find this. We have to first say, what is f of x, what is g of x? Let's subtract them. Now, on the first one, we just could say, yeah, we're adding these together. That's very quick. The second one, when we subtract g of x, make sure that you're subtracting the entire piece. So if g of x has more things with it, we are subtracting each piece. And when we subtract that 3x, we get negative 2x plus 2. On the next example, we have f times g of x. That means we have to write out what the definition is, and then it's coming down to plugging things in and performing operations. F of x was x plus 3. We're multiplying that by whatever g of x is. G of x is 3x. So when we multiply it, make sure that it does get distributed. We get 3x squared plus 9x. If we're asked to find the quotient, so we have f over g, and it's all of x, then we have to take f of x, put it on top, g of x, put it on the bottom. At this point, it's okay to leave it like this. The second part of this, though, is we have to say what x can be and what x cannot be. So when you're looking at a fraction, normally you look at the bottom and you say, we don't want the bottom to be a 0. So if we set 3x equal to 0 and we solve for that, we say x cannot equal 0. And again, the reason that x cannot equal 0 is if it did, and we plug 0 in for x, we would get 0 on the bottom, which is not what we want. At this point, I'm going to go through a series of problems. I think it's the most beneficial, since you've seen the types of problems on the last slide, that you do the problems and then you check with my work and see where you may have gone wrong if you did. Example 1, you're given two functions. You're asked to find f plus g of x. So my first step is always to write f of x plus g of x. Our second step is always to just plug in what is f of x, what is g of x, and add them together. F of x has been written. I'm adding g of x. And then I'm combining the like terms. And when I combine the like terms, I get a final answer of x squared plus x plus 6. Part 2 gives us the same two functions, and now we are doing f minus g of x. So again, our first step is to write f of x minus g of x. Now we plug in. I've plugged in my f of x function. I'm subtracting my g of x. Notice g of x is 4x plus 5. I'm subtracting that whole piece. Make sure that you open the parenthesis and show that you're subtracting the entire g of x. At this point, you want to distribute the negative and make this minus 4x and minus 5. And from there, you want to combine your like terms to reach your final solution of x squared minus 7x minus 4. On the next example, I want you to pay very close attention to the notation. The notation is saying f times g, this dot always means multiplying ever since you've seen it, and then we're taking it of x. So our first step that we're going to do is we're going to write f of x times g. Just like the previous problems, now we're going to plug in what is f of x, what is g of x, and then multiply them together. We have the two functions multiplied together. That means that each part of the first function has to be multiplied by each part of the second function. A good way to do this is to start with the first one and say, let's multiply this here, and then go to our next term, do a similar thing, and finish with our third term. So when I multiply x squared times my two terms on the right parenthesis, here's what I get. When I multiply the positive 5x by both terms over here, this is what I would get. And when I do negative 1 times both terms, at this point I want to combine like terms to get to my final solution, which is 3x to the third plus 13x squared minus 13x plus 2. Our next example is one that has a division. It has f divided by g and taking it all of x. If you look at that first slide, that reference slide, our first step is to write f of x over g of x. At this point, we want to plug in what is f of x, what is g of x. F of x is x squared plus 5x minus 1. G of x is 3x minus 2. This is pretty much it for this example, except for the bottom of this fraction cannot be a 0. So what we want to do is we want to say whatever the bottom is, it cannot equal 0. So this line through the equal sign means cannot equal. It's going to be treated the same way as an equal sign as we solve for x. And as we discover, x cannot equal 2/3, and it's always a good practice to just double check this, see what happens when you plug 2/3 into the bottom. You should get a 0. Remember, on this type of problem, we need two parts. We need the f of x over g of x, and we also need the domain. What can x not equal? That is it for those operations of functions. The next type that we're going to look at is composition of functions. So what happens in a composition is a function is performed, and then a second function is done on top of it. So this is what they would ask you to find. Using that, this would be our first step. On the bottom would be, the reason we write it like this is because we know what the g of x function is. So we're going to replace g of x with a function. I want you to pay close attention and note that this is very different from what we saw earlier with f times g of x. These are not the same thing. They are treated very differently. So please take note of it and please pay close attention to that portion. How this is read f of g of x. Remember, our first step was to write f, and then we have g of x inside it. So if you notice, these two kind of go together and they form this. And then the f is still on the outside, so we're going to take whatever g of x is and plug it into f of x. Our first step is just going to show what is g of x. So we look up here and they've given us this g of x function. We're saying g of x is this. So instead of g of x, I write this, and now I say I want f of this. Knowing what you do about functions, if you know that f of x is this, then if we want f of x squared plus x minus 1, then we take this function and instead of x, we plug in this portion. So we have x squared plus x minus 1, and it's still plus 3. Now we combine our like terms, and we got x squared plus x plus 2. A quick review. The first thing we did is we looked at this when we said this was f of g of x. So we said we want g of x, and it goes right here. Now we have f of this g of x function. Plug in what you know. You know g of x is given up here, and now we use our function rules to take this chunk of information and to plug it into our f function instead of x. And that's how we solved it. We can go in either order. So we could do g of f or f of g. At this point, we're going to do g of f. Remember, we take these things that are two closest together and we say that's what's going to go in our parenthesis. And we are going to take g of f of x, which, if you notice, is kind of read the same way. G of f of x. G of f of x. So we know what f of x is. So instead of writing f of x, we're going to write x plus 3 because right up here they told us that's what f of x was. So now we have g of a certain chunk of information. So we go back to our g function and we say for every x, we're going to plug in x plus 3. So notice this is my g function, but instead of x's, I have x plus 3. So here's it squared, here's a single one, and minus 1. Now we'll want to simplify and combine like terms. Notice x plus 3 squared is just x plus 3 times x plus 3. So we will have to distribute, and that's plus the remaining terms. You can check your simplification at this point, but you should end up with x squared plus 7x plus 11. In the next example, they tell you x equals 2. What I would do is I would set it up the exact same way we set up the last problem. I would start with g of f of x, g of f of x. Instead of x, we would say x is now 2. So I'm going to plug a 2 in. Now, what is f of 2? If we wanted f of 2, we would plug 2 in for x in your f function. So f of 2 is 5. Now we have what is g of 5. If g of x was this function, then we know that g of 5 would be that function except 5's in for x's. And our answer would be 29. We can also do f of g if it is a discrete function. So what it means when it's discrete, it means it's not continuous. There's only a certain set of points that make up this function. It's not a line, it's not a parabola, it is just these 4 points. In this case, the second letter that's given, so f of g, g second, we're going to evaluate g of x first. If this was g of f, we would do f first. So we start with our g function, and we look at, we're going to take each x value, so we're going to have a total of 4 different things that happen. We're going to start with our very first one, which was 5. So what we're going to end up doing is this f of g of 5. We know that in the g function, when x is 5, y is 7. So at this point, we are going to do f of 7. In our f function, when x is 7, y is 8. So we have a point that was x was 5, y was 8. This point is in our f of g function. Now we're going to go to our next x value in the g function. Remember, we're evaluating g of x first. And then we're doing f of that because we want f of g. So when x is 3 in the g function, y is 5. Now we want f of 5. So we look to our f function. When x is 5, y is 3. So we add 3 and 3 as a coordinate that is in f of g. Our next x value in the g is 7. So we're going to do g of 7. G of 7 was 9. So we are doing f of 9. F of 9 is 8. So we get a 0.78. X was 7. The output was 8. And our last x value for in the g function was 9. So that's the one that we're going to do. So we end up with f of 11. In the f function, when x is 11, y is 4. So we get a 0.94. We would list these as a solution set. Notice you'll see in the next example, every time we have a g or an f in the parenthesis, it won't always have a corresponding point. And you're going to see that in the next example. So again, since f is second here, we're going to evaluate f of x first, and we're going to evaluate each x value, and this is how we're going to set it up. I want you to finish this problem on your own, and you can check your solutions with mine.